Okay, welcome everyone to today's lesson. In today's lesson, we are looking at the representation, okay, of sets. Okay, so that's the topic that we are going to do, which is mathematics. Okay, so in this lesson specifically, we want to actually we already defined a set, okay, but we are saying we want to define a set. And then we want to talk about the different ways in which we can represent a set. Okay, so we have what we call as the verbal descriptive form. And then we have what we call as the roster form. Or you can, this roster form here is the same as the listing form. And then it is also called as the tabular form. Okay, so if you see any of those three words, it means the same. And then we can talk about the set builder form of representing a set. And then the last one there is Venn diagrams. Okay, so I'm not going to talk much about Venn diagrams because I know we've been doing Venn diagrams, okay, since, I don't know, grade 10 up to grade 12. We've been doing these Venn diagrams, okay? So my focus will be on the set builder form, the roster form, and this descriptive form. Okay, so that's how we are going to move in today's lesson. Okay, so if you have your mic unmuted, make sure you just mute it, right? You only unmute your mic when you want to ask a question. Okay. Okay, so the first thing there, we are going to define what a set is. And we all know that a set is just a collection of well-defined objects or elements. Okay, and then this can be an example of the set. So we say this is a set of even numbers. You can see we are going from 2, 4, 6, 8, 10. Then we are continuing like that. So we can say this is a set of well-defined objects or well-defined elements. And in this case, those elements, we're just saying they are even numbers. So that is a definition of the set. And then now we want to talk about the description, okay? So I said we have different methods of defining or describing a set. Okay, so we have 3 ways, or I can say 4. Here I can add 4, which is the Venn diagrams, but I'm not going to concentrate much on these Venn diagrams, okay? Okay, so we can say we have 4 ways in which we can describe a set, okay? So we have one, which we call as the roster notation or the listing or the tabular, okay? And then the second one is what we call as the verbal description method or verbal description form. And then the third one is what we call as the set builder notation or the set builder form. Okay, so we go straight into describing what each and every method looks like, right? Okay, so we have the first one, which is the roster notation there. So this roster notation means you're just listing the elements that are in a certain set, okay? So you can see I have set A here, and then in this set A, I have R, A, E, O, U, okay? So this is a set. I can represent it in listing form or roster form, okay? I can also represent this same set here in a verbal description, okay? So in a verbal description, we're going to say this set A is the set of the vowels in the English alphabet, okay? We know that those are A, E, O, U, they're just vowels, right? Okay, so in the English alphabet. So we can describe this set in terms of listing the vowels like that, or we can describe it by just a verbal description of what we're talking about, okay? So in this case, we're just saying that is a set of vowels, okay? And then this same set here can also be represented in what we call as the set builder notation, Okay, so in the set build annotation, you are going to say this set A is a member that contains X, such that X is a vowel in the English alphabet. Okay, so let's go now deep into the details of what each of these mean. Okay, so if we talk about, if we can start with the verbal description, which is the simplest. Okay, it's the simplest. So in the verbal description there, I was saying it is a method of describing sets in words. Okay, so in here you are going to think or to analyze what would be the best description that suits the case. Okay, and then here I'm saying let's try to describe the sets in the next slide there. I don't know why I wrote previous here. Okay, so let's try to describe these sets here using words. Okay, so set A, set B, set C, and set D. Okay, so if we go to set A there, we can see that set A contains 1, 2, 3, 4. Okay, so how can we describe that set in terms of words? Okay, so if I'm too fast or if you don't get anything, just unmute yourself and ask, right? Okay. Okay, so we are saying if I have a set A there, and this set A contains 1, 2, 3, 4, I can actually describe this set using words. Okay, so I can say this set A is just a set of all the it's a set of the counting numbers that are less than 5. Okay, so what do we mean by this statement here, counting numbers? Okay, so counting numbers are just numbers that start from 1 and then they are going to infinity. Okay, you can 1, 2, 3, 4, 5, just like that. Those are counting numbers. So counting numbers start from 1. And then here I can see I have 1, 2, 3, and I'm ending at 4. So I can describe this set as a set of counting numbers that are less than 5. Or you can also describe it in other ways. You can say set A is just a set of counting numbers from 1 to 4. Okay, so it's the simplest description there. You're just using weight. So what you are seeing, you're just putting it into weights, right? So that can be a way we can represent this set A here. Then we move to the other one, which is set B. Okay, so here I was supposed to write set B. I don't know why I wrote here. Okay, so we are saying, let's describe this set in terms of words. Okay, so this set is just a set of the letters in the word Philippines. Okay, so we know that when you are representing a set, if a certain element appears twice, we don't write it twice in the set, right? Okay, no wonder here in the Philippines word, you can see we have 2 P's, but in the set, we only write 1 P. Okay, we have 2 I's here. In fact, 3 I's here, but in the set, we only write 1 I. Okay, so this set B, we can actually represent it. Okay, in terms of words, we are saying the set B is just a set of letters in the word Philippines. Okay. Okay, and then we can move to the next one here, which is set C. Okay, so on set C here, we can see that this is a set that goes in factors of 5, right? Or in multiples of 5. So we are saying 5, 10, 15. It means the next one here will be 20, 25, 30, just like that. Okay. Yeah. Okay, so we can actually represent this set here that we are seeing in verbal form. Okay, we can represent it in words. So we can say set A is just the set of, this is set C. Why was I writing A? Okay, so the set C is just the set of all the positives multiples of 5. Okay, why are we saying all the positives multiples of 5? Because we can see these 3 dots here at the end, right? So this indicates that the sequence there is still going. So you can go to 20, you can go to 25, you can go to 30. This should be 30. You can go to 30 until forever, right? Okay. So we are seeing that this set E here is actually a set of all the positive multiples of 5. Okay, we would have represented that set in terms of Okay, so that's enough about label description. Let's go to the roster form or the listing notation. Okay, so here we are just listing the sets, and I'm sure you're common or you're familiar with this type of representation because it's the one that we are using. Okay, so here I was saying in this method, okay, we describe a set by listing each element of the set inside these curly brackets here, okay? So we list each and element of that set inside these curly brackets here, okay? And then, okay, so it's important to note this that I put here. I was saying in listing the elements of the set, okay, each distinct different element is listed once, okay, but the order in which you are listing does not matter. So meaning I can have a set where I can say 1, 2, 3, and then I can also have a set where I can start with 3. I go to 1 and I go to 2, okay? So the order doesn't matter, but you just don't have to repeat. If any element appears more than once, you don't have to repeat, okay? So that's the roster form there. Okay, so an example is what we have on our screen here. We are saying, if we have an example, the set of all the vowel letters in the English alphabet, it means we can represent these words here. We can turn them into the roster form or the listing form, of which we can just say, let this be set J, okay? And that set J contains A, A, I, O, U, okay? Yeah, so all the elements here are separated by a comma. And then at the beginning there, you put a curly bracket. And then even at the end there, you put a curly bracket like that. Then it will mean that you've actually represented this set in roster form or in listing notation. Okay, okay, and then this is another example. Okay, we have been given a set example there. We're saying the set of integers between 0 and 5. And we know that integers are just those numbers on the number line. Okay, so the positive numbers, the negative numbers, including what? The 0 itself. Those are what we call as integers, okay? So here they're saying represent the set of integers between 0 and 5, okay? So it means you are not including the 0, you are not including the 5. So between 0 and 5, what do we have? We have 1, 2, 3, 4, right? But actually you can write it in any order you want. So the order doesn't matter, okay? The order doesn't matter. So you can see that this set here that is being described in words, we can list it down here to have 3, 2, 1, 4. Or if you want, you can put them 1, 2, 3, 4. It will be okay. Okay, so that's about listing. And then this is another example. I'll upload the notes for you to actually go through. Okay, and then in this listing notation, okay, we have what we call as the ellipsis, okay? So those 3 dots that we put if the set is infinite, okay, we call them as the ellipsis to indicate that the elements in that set, okay, that there are elements in that set that have not been written down. So meaning that the set continues, okay? It continues to a large set, but we can't represent all those elements on paper, right? There will be no space. So we just use this to my 3 dot dot dot. Okay, so if you didn't know the name of these things here, today you've known that they are called as ellipses. Okay. Okay. And what do they mean, these 3 dots? They mean and so on and so forth. Okay, and so on and so forth. So you should tell someone today that I've known what these 3 dots mean. They mean ellipses. Okay. Okay, and then we can go to the set builder notation. Okay, so this one is the one that is a bit challenging because the questions that will mostly come, they will have a representation of the formula, okay? And those formulas there, they require thinking, okay? So for you to actually get the answer correct, you need to think, okay? If you don't think, you can't get the answer correct, okay? So the set builder notation is what you should focus on a lot, okay? Because it is what confuses today. So let's define what it is, okay? So, okay, so set builder notation, we have the definition here. I was saying that it is the method that lists, okay? It is the method that lists the rules that determine whether an object is an element of that set, okay? Rather than showing the actual elements, okay? So we're just going to describe that in this set, okay, there will be such and such elements, but not actually showing the elements, okay? So it's like, what can I say? It's like we are putting that description in words, we are putting it into a formula, something like a formula, okay? That's what we call as set builder notation. Okay, so let's try to look at some examples here. Okay, so, okay, before that, the set builder notation is represented like this, okay? And it is important to know what each of these mean, okay? So I can have, maybe this is my set Z is equals to, okay? I have an open curly bracket here. In this case, this open curly bracket, it will mean the set of, okay? And then I have an X here. So we say the set of OX. So whatever variable you're going to put here, it will mean that OX or OP or OQ, whatever you choose to put here, whatever letter you choose to put there, okay? So the bracket there means the set of OX, and then this line here, the straight line here, it means such that, and other people, they use a full colony like that, okay? So if you see the full colony like that, or you see just a straight line like that, that line means such that, okay? So a set of OX such that AX is a member of natural numbers. So this is just an example, okay? So this symbol here means member to, or actually belongs to, okay? So this is what we call as the set builder notation. Okay, so all the expressions that we are going to have in set builder notation, they are going to be in this form like that. Okay, so now let's go to the example that we see. Okay, so for example, we have set A here, which has 1, 2, 3, 4. Okay, so we can actually represent this set in set builder notation. Okay, so we'll say let X represent these members that are in that set, right? Okay, so we are going to say set A, okay, is a set of all X. Okay, so set A is a set of all X such that the X is a counting number that is less than 5. So that will be our representation there, okay? Okay, so that will be our representation there. So set A is a set of all X such that this X is a counting number that is less than 5, or you can say set A is a set of all X such that X is a counting number, okay, from 1 all the way to what? To 4. It means you would have represented your set in set builder notation. And then I also have another example here. This is about what? Okay, so this is about colors. I was saying we have a set E here that contains red, yellow, and blue. So we can actually represent this set here in set builder notation. Okay, so we can say set E is a set of all X such that this X is a primary color. Okay, so you can see we're just describing what the set is without actually showing the elements in that set. So that's what set builder notation is all about. Okay. Okay, so we move forward. This was I think I was trying to give an example here. I was saying this set S is a set of all X's, okay, such that the X is greater than 3. and x is an odd integer, okay? So meaning we have two conditions here. The elements that are going to be in this set, one, they should be greater than 3, and then 2, they should be an odd integer, okay? Meaning it cannot be divided by 2. So if we are to list this set, from that set build a notation to just listing it, okay, we'll start at 5, then 7, 9, 11, 13, 15, just like that, okay? So that's what that set there will represent. And then I have another example here. I was saying, if I have a set H, okay, I'm going to say this is a set of OX such that AX, okay, is between, or we can say X is between 2, okay, and 3. Okay, and then there's another condition here where they're saying X is a counting number. And what did we say counting numbers are? We start from 1, 2, 3, 4, and then we go on indefinitely like that. Okay, so do we have a counting number that is between 2 and 3? Okay, do we have a number that is between 2 and 3? That is a counting number. We do not have, because between 2 and 3 you just find my 2 point something, 2 point something, 2 point something, and 2 point something cannot be a counting number. Okay, a decimal number cannot count. So between these 2 and these 3, okay, there are no counting numbers. So it means set H is just a what? An empty set. It has nothing in it. Okay. Okay, and then this here again, I was describing what set build annotation is. You can actually go through this when I upload the notes. Okay, and then now let's go to the sample exam questions. Okay, so we know how to actually solve these questions. Okay, so I think I have to move from the full screen mode. Okay, and then I'm going to, let me share the screen again. Okay, so we want now to look at the sample exam questions. Okay, so where are the questions? They are down here. Okay. Okay, sample exam questions. We have exam questions there. Okay, so let's try to actually solve some. Okay, so the first one there, they're saying represent the following sets in set builder form. Okay, so they have given us a set that is in roster form, and then they want us to represent it in set builder form, right? Okay, so if we get the first set there, what are we going to have? Okay, so let me go to the other board. Okay. Why is it not open? Okay, so let's solve this one here, and then even that one, okay, and then even this there. Okay, so what is this? Oh, I was teaching something. Okay, so we are saying that we want to turn this set into set builder notation. So we have 2, 4, 6, 8, and then we have those 3 dots there. That means that the set is continuing. Okay, so how can we actually represent this set in set builder notation? Okay, so we first have to identify the pattern of these elements that we have here. Okay, so we can see that each element is actually just differing from the other by 2, or we can say, yeah, it's differing from the other by 2. Okay, so from 2 we go to 6, we go to, from 2 we go to 4, we go to 6, we go to 8. It means the next one is 10, 12, just like that, right? Okay, so we can actually say that set A is a set of all the x's such that this x, okay, such that the x is an even number, okay, such that the x is an even number. Okay, so this will be the representation in set builder notation. Okay, so if I give you this set here in set builder notation, it means you can be able to list it and you come up with that set. Okay, so set A is a set of all the x's such that the x is an even number. Okay, we can see that it actually works. So even numbers start from 2, 4, 6, just like that. Okay, so this one is simple. This one was the first one. So this is A, and then we solve the first one. Let's look at B. Okay, so B, we have this one here. So B, we have 1/3, 1/2, 3/5, 2/3. So let's represent this in set builder notation. Okay, so we are going to say the second one there. What do we have? Okay, so we have set B, which is actually 1/3, 1/2, 3/5, we have 2/3. Okay, so this is what we have as our set, and then we want to represent this in set builder notation. Okay, so before you represent in set builder notation, you always have to identify a pattern between what we have here. Okay, so can we identify any pattern moving from 1/3 to 1/2 to 3/5 to 2/3 there? Okay, so in this case here, you do not have any pattern there. Okay, you do not have any pattern. So it means in your set builder notation, you can actually just state that the x will actually come from this set. Okay, so we can say let x be the random variable that represents all these entities in here, right? So we can actually represent this. Okay, so I was saying the numbers here do not have a pattern, but they have something in common. We see that they are all fractions here, okay? And a number that is represented in fraction form is what we call as a rational number. Okay, so the only thing that is common about these numbers here is that they are rational numbers. So rational numbers are numbers that can be represented in the form A/B. In short, numbers that can be represented as a fraction are what we call as rational numbers. And they are represented by the symbol Q, like that. Okay, so if you see in math, they just put a Q there, it means they are referring to rational numbers. Okay, so these are rational numbers, but they do not have a specific pattern there that we can follow, right? So we are going to say set B, okay, is a set of all x, okay, such that the x is equals to A/B, okay, because these are rational numbers, okay, such that x is equals to A/B, and A will actually be a member of the numbers that are on top there. So we're just going to get the numbers that are on top. So 1, 1, 3 there, and then 2. And then we can say the B is actually a member of the numbers that are down. So the numbers that are down, we have 3, 2, 5, then we have 3. Okay, and then we can close the set here. Okay, so we can see that set B is a set of all the x's such that this x is a rational number here. You can see I've put that it's equals to A/B, meaning it's a rational number, such that the values for the A here are coming from this set. So you just get the values that are on top there. And then the values of this B, they are coming from the values that we have below there. Okay. So this is one of the ways we can represent it in set builder notation. And then another way you can say B is a set of all the x okay, such that this x is a member of rational numbers, okay, and then this x is actually a member of, and then you just list the actual set that we had there. So we have 1/3, and then we have 1/2, and then we have 3/5, and then we have what is that? We have 2/3, okay, and then you close it like that. So you can actually represent this set in two forms. So you can actually represent it like this, or you can actually represent it like that. Okay, do we have any questions there? Anyone with a question there? Okay, we don't have a question, so let's continue. Okay, so now let's look at the question B here. We are on this B question. They're saying write the following sets in roster form. And we said roster form is just what? Listing, right? And this form is also called the tabular form. Okay, so the first set there they've given us, the set P, okay, is a set of all the x such that the x is a member of integers, and this x is between 2 and 5. Okay, so let's represent this in roster form. So we are saying we are on B now, and we're on the first question. We're saying we have a set P, okay, which is the set of all the x such that this x is actually a member of what? The integers, okay? But we have another restriction that this x should be between 5, okay, and what? 2. So this is the set that we have there. Okay, so how can we represent this in the listing form, okay? So we first have to understand what integers are. So we said integers are the numbers on the number line. So 0, 1, 2, 3, and then this side you have -1, -2, -3, okay? So integers are these negative numbers, positive numbers, including 0, but no fractions should exist, okay? So we don't have 1 point something in integers, no. They are just whole numbers, but they can be negative or positive, okay? So meaning we are just looking for the integers that are in between 2 and 5, with 2 and 5 inclusive, okay? Because here I have this sign that has an equal to down in there. So we are going to say, if we are going to list this set, we are just going to say it's a set that starts from 2, 3, okay, 4, we're going to say comma 5 there. And then we put a closed curly bracket there, okay? So this is the set when you list it. Okay, so if you have any question, please feel free to ask. Okay, don't die mukat. In fact, this is online learning. So no, so if you don't get, please ask, right? Okay, so let's look at the second one. What is the second one? The second one, we have the set Q, okay, where we are saying that it's the set of all the M's such that this M is a letter in the word osteoarthritis, like that. Okay, so someone is asking a question.
I was kind of asking if you can repeat.
I repeat on this part here.
Yes.
Okay, so here we've been given a set that is in set builder notation. Okay, so I have defined what set builder notation is, and it looks something like that. Okay, so we have been given that this is a set P such that the X is a member of the integers, okay, and that X should be between the numbers 2 and 5. Here you can see this X should be between this 2 and that 5, okay? So now they're asking us to get this set and actually represent it in roster form. So what did we say the roster form is? We said the roster form is just the form where we are listing each and every element of the set, okay? So these integers are just all the positives and all the negatives, including 0, okay? but there should be no point something in those numbers. Okay, so if I'm getting integers that are between 2 and 5, I'll just list the integers from 2 up to 5. Okay, so you can see here I was listing that this set P is actually, I've listed my first element there, which is 2, and then I go to 3, I go to 4, and I go to 5. That's how I ended up with this set here. I don't know, is that clear? The one who asked the question. Is that okay?
Yes, it's clear.
Okay,
Yes,
so
it's clear.
now we are saying we've moved. We want to show this set that we have there, okay, in roster form. Okay, so we are saying this is a set of all the M's such that M is the letter in the word osteoarthritis. Okay, so by just looking at this set, we can see that it's an empty set. Okay, so because it's a set of all the M's such that this M is in this word osteoarthritis. But in this word osteoarthritis, can we see any M here? We can't. Okay, so meaning that set Q actually is just an empty set. Okay, this is an empty set there because we don't have the letter M in this word osteoarthritis. Okay, if you have any question, you're free to ask. Okay, so that's how we can answer the second one there. And then C is on types of sets. Okay, so the things I was talking about in the previous class, I was saying a singleton set is the one that has one element. An empty set does not have any. An infinite, okay, it will have a countless number of elements. You can't count them. So we can actually even just do these three here. So we are saying which, with only one of the following, okay, classify the sets and give the reason why. So here we have the set X here, that they are saying that this set X is a set of all the X's such that the X, okay, is less than 0, but is greater than 2, okay? But the X is a natural number, okay? So is this a singleton set, or is it empty, or it's an infinite set? Anyone who can try? Anyone who can try that out? Is that a singleton set, an infinite, or an empty set? Okay, so we can see that this X here, it demands that, okay, someone has said it's a singleton, but let's actually prove it, okay? So we are saying this X, it demands that X is a natural number. And I said natural numbers are just counting numbers. So they start from 1, 2, 3, and like that, okay? And then here they're saying this X should be gotten from 0 to -2, okay? So -2 there is not included because we only have that sign which is greater than, okay? And then the 0 is also not included. So it means the numbers that are between -2 and 0 are the ones that are in that set, okay? Are the ones that are in this interval, not that set, are the ones that are in that interval, okay? So do we have any natural number between -2 and 0? We do not have any natural number, okay? We do not have, because the natural numbers start at 1. So one is somewhere there, but they want this interval is giving us the numbers that are between -2 and 0. So this set X here is actually an empty set. It doesn't have any counting number, okay? And then set Y, they are saying set Y is a set of all the X's such that X is an even number and X is also a prime number, okay? So is that a singleton set? Is that an empty set, or it's an infinite set? Anyone who can try? Okay, so here you just have to know what an even number is and what a prime number is. So even numbers are 2, 4, 6, 8, until forever, right? But what is a prime number? A prime number is just a number that has only 2 factors, okay? Itself and 1. Okay, so which prime number do we know that is even? Okay, so it's only 2. So 2, it's a prime number because it only has 2 factors, itself and 1. And then it's also an even number, okay? So it satisfies this condition here. So in this set, you're just going to have 2 as your element like that. So this set here will be classified as the singleton set. It's single, it's just one element, okay? And then this one definitely is an infinite set. You see that it's 1, 2, 3 until it goes forever, right? Okay. Okay, so we can move from this. This actually we did it in the previous class, okay? But I just thought it was maybe we can also solve some of those questions. Okay, so let's solve these questions here and then we can call it a day. Okay, so the first one here, they're saying, okay, don't mind these ones here per first. These are just definition of the set. So we are starting on this C question here. And then we also want to solve D there. Okay, so they are saying write the following sets in roster form. So meaning we want to list the elements that are in this set A here. Okay, so let's get the description of this set and then try to list it. So they're saying set A is a set of all the x's such that x is a 2-digit number such that the sum of those 2 digits, okay, is 8. Okay, so that's the set builder notation. And then we want to convert it into the roster form. So we want to list all the elements in this set. Okay, so I can say set A, and then let's list the elements in this. So what is the description? So you just follow the description. So they are saying set A is a set of all the x's such that the x is a 2-digit number, okay, such that the sum of those 2-digit number is 8. Okay, so we are saying x is a 2-digit number. So meaning x should look something like AB. Okay, there should be 2 digits there. And those 2 digits here, when you add A and B, they should give you what? 8. So those are the elements that are going to be in this set A. So the first one we can see if I get 1 and 7, so I can write 17 here. So 17 will be a member of this set because 17, 1 is a 2-digit number. And if I add 1 plus 7, I'm going to get 8, right? I hope you are seeing the picture. And then I will say comma. The other one can be 2 and 6. The other one can be 3 and 5. Okay, the other one can be 4 and the same 4. The other one can be 5 and 3. The other one can be 6 and 2. The other one can be what? The other one can be 7 and 1. And then we can also have another one where we have 0, 8 and 0. Okay, so it means even here per first step we can put a 0 and 8. Okay, so comma there. And then you close the set. So this set here will represent a set, okay, where you have x as a 2-digit number, and then when you add those 2, they give you what? 8. We can see when I add 0 and 8, 8, 1 and 7, 8, 2 and 6, 8, 3 and 5, 8, 4 and 4, 8. All these will give me 8. So it means I've represented this set here, okay, in roster form or in listing form. Okay, and then let's try to also solve for B here. So B, what are they saying? So on B, they're saying that set B, okay, is a set of all the x's such that this x is equals to 1 over n squared, or n to the power 2. Okay, where this n is actually a natural number. So we know that natural numbers start from 1, 2, 3, 4, 5, 6, going just like that, right? Okay, so we can say set B there is equals to, and then we try and list. So x is given by the formula 1 over 1 squared. So it means our first element here will just be 1 over 1 squared, comma, 1 over 2 squared, comma, 1 over 3 squared, comma, 1 over 4 squared. And then we can continue going because these natural numbers do not end. We can keep on counting and counting. So we'll just put ellipse here. So we put the 3 dots like that to show that this set continues to grow without bounds, right? Okay, so this here will be the representation of the roster form for that set in set builder notation. Okay, so do we have questions there before we go to D? Okay, silence means it's no question. Okay, so on B, we are now doing the opposite of what we are doing on C. Okay, so on C, we are given the set builder notation, which is also known as the rule method. Okay, and then we were converting to roster form. Okay, but on D here, okay, we are given the rule method, which is just set builder notation, right? And then they're asking us, here we are given the roster form, and then they're asking us to convert it to the set builder notation, which is also known as the rule method. So how are we going to actually write this set here into the rule method? Okay, so we can see that these questions, I don't know how they put them, but they are just opposite of each other. So this description here is actually the answer for this. And then this guy here is actually the answer for that. Because we can see that this is just a set of 2 digits such that their sum is 8. Okay, we can see 1 plus 7, 8. Okay, so for you to write in set builder notation, you write it like this. Okay, you write it like that. So we're going to say x is that x is a 2-digit number such that the sum is actually what? 8. Okay, and then we can also see that B, it is actually the same thing, but the only difference is that in this set here, they're just ended on 5. Okay, but in that set here, they are going to infinity like that. So you can see that this set here, the B, is actually this representation. If I can write it again, it will be 1 over 1 squared, comma, 1 over 2 squared, comma, 1 over 3 squared, comma, 1 over 4 squared, and then comma 1 over 5 squared. We can see that, right? Okay, someone has raised their hand there. You can ask your question, sir.
Sir, you can see that on what you've given us on A, there's no 44 there. So do you have to write a condition inside your braces?
Yeah, I can see. Yeah, I can see. There's no 44 here. Yes, there's no 44. Yeah, so if you remove one element from that set, it won't make the answer wrong. It will still be true because when we add the numbers, we're still getting what? 8, right? So even if one element is missing there, it will still be the same. You can see that here it starts from 1 and 7, but mine I started from 0 and 8. And then there's also no 4 here, okay? So the answer doesn't change. It is still correct. The description is still the same, okay? Okay, and then this one that we have here, I was saying it is a form of 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, 1 over 5 squared, right? So how do you represent this now in set builder notation? So let me create some space here. Okay, so this one will be the similar set notation to what we have here. So I'm just going to say B is a set of all the x such that, okay, such that the x is equals to 1 over n squared, okay? But the x is actually, but this n here is actually a natural number, okay? Okay, so this n is actually a natural number, and that natural number should just be between what? Between 1 and 5. You can see that, right? So we're going to say that natural number should be between 1 and 5. So the n should be between 1 and 5. And then you close the set. Okay. So this here will be the representation in set builder notation form of this set here. Okay. So do we have any questions there? Any questions, guys? Okay, no questions. That's good. Okay, but I hope you've understood something. I really hope so. Okay. If you don't understand anything, I'm always there. You can just inbox me on WhatsApp. Okay, and then down here, I've put a lot of questions for you guys to actually try it out. Okay, so you can try to solve a question, and then you send me the solutions. Then I'll be able to help. Okay, I'll be able to. Okay, so I've put a lot of questions here, as you can see, represent this in roster form, different questions here. There are a lot of them. So I have other questions there. I think I should change this. I think it's not visible. Okay, I will change this before uploading the notes. Okay, we have more questions there, so you can try them out. So you just know the concept. Okay, no wonder I put a lot of questions there. Okay, so we are done. Okay, so if there are no questions, then have a blessed night. So I'll continue the lessons tomorrow.